This video will go over graphing again, but this time the equations are going to be given to us in standard form. So that means it's the form where you can't just look at it and know the vertex. So if we recall when the equation looks something like this, okay, this is called vertex form. So if I wanted to know what the vertex was, we could just look at it and it's always the opposite of this, and then this number out here. So H and K. However, if we take a look at our problem in our notes, that is not the form that we are given today. So if we want to find the vertex, we can't just look at it and know in 2 seconds. So to find the vertex here, we are going to need our vertex formula. So the formula to find the vertex is negative b over 2a. So if I want to find my vertex x value, I have to do negative b over 2a. So this is a, this is b, and this is c. So it's negative 4 over 2a. And then negative 4 divided by 4 is negative 1. So we just found out that the vertex's x value is negative 1. So then to find the y value, or the second value here of our ordered pair, we're going to go ahead and plug in negative 1 for x. Order of operations, we do exponents first, and then we multiply. And then we add and subtract lastly, so we get negative 3. So now we have our vertex. So negative 1, negative 3. So right here. Okay, so to review a little bit, we know that when the leading coefficient, so when the a value is positive, we know the graph is going to go up. So we know this graph will go up and not down. And again, we know that because a is 2. And then, so if the graph is going to go in this manner, we know that the vertex, this point right here that we just found, is the very bottom. So we call that the minimum of the graph, the very bottom. So the axis of symmetry is going to be that line that cuts the graph in half. So it's going to go right here. So the equation for that vertical line is x equals, so think of x like how it makes a V up here. So it's x equals, and the number that x is right here is negative 1. Or the other way to think about it as it's the x value of the vertex. So x equals negative 1. Okay, it doesn't say to make a table to graph this. It wants us to find the x-intercept. So since we don't have the graph, you could make a table and graph it to find the x-intercept. But I'm going to go ahead and use algebra. So to find the x-intercept, remember f of x is the same thing as putting a y there in its place. So to find the x-intercept, I'm going to leave the x's in the problem and replace the output here with a 0. So to find the x-intercept, we have to solve this equation. You can try factoring, quadratic formula, completing the square. So I'm going to go ahead and use the quadratic formula to solve this. So we learned in this chapter that when it equals 0, that we can use to find x, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we plug in our values. Or you could try factoring again if you want to see if this is factorable. And then we get positive 8 here. Doesn't say to leave our answer as a decimal, so we're going to go ahead and simplify the square root of 24, just like we learned how to do last chapter. Get 2 root 6 when we simplify 24, square root of 24. And then after we simplify the square root, we look and see if anything can go into all three of these numbers here. And so 2 can go into all of these numbers here. So we would get -2 plus or minus. 2 divided by 2 here is just 1, so we don't need to put it. Okay, so the x-intercept, we have 1 at -2 plus radical 6 over 2, comma 0, because that's what y is. And we have 1 at -2 minus square root of 6 over 2, 0. You can also write it for me, again, on Alex or online. You'll have to see how they want it. If this was a paper and pencil test in the future, you could also write it like this. Now, since I want to use these points to graph, it doesn't say you need a decimal, but if I want to find out where it crosses this x-axis, this means nothing to me. I need to put it as a decimal. So I'm going to enter this in my calculator as -2 plus the square root of 6. Now I can't click divide because then it will just divide the radical part. So I'm going to click equal. So it computes the numerator and then divide by 2. So this one here is about 0.22. So if I was going to graph this, I would go over to just a little bit, about like right there. Okay, now I'm going to put this one in the calculator. I'm going to show you a different way. If you want to enter this whole thing in the calculator, you need parentheses around the numerator. So -2 minus the square root of 6. So all of that in parentheses, and then divided by 2. Or you do it the first way I showed you. So this comes out to be -2.22. So to graph that, I'm going to go to -2 and just a little bit over and like right there. And if you did it correctly mathematically, it should look the same distance away on both sides. So you could see it's a whole box away and just a little tiny bit. A whole box away and a little tiny bit. So it makes sense, our answer, because it should be whatever's on this side, there should be one equidistance on the other side there. And so far so good. It's going to go up if I were to connect this. Alright, so now it asks me to find the y-intercept. So to find the y-intercept, I'm going to leave the y in the problem, and I'm going to plug in 0 for the x's. So I'm going to leave the y to find the y-intercept. Whoops, to find the y-intercept, I leave the y there and plug in a 0 for the x's. So exponents first. So we'd get 0 plus 0 minus 1. So we just get -1. So when x is 0, y is -1. Okay, so now we're going to graph this point. 0 and then -1. So right there. Now, if I have a point here that's 1 away, I know I'm going to have 1 over here. Now it says check with the 1-3-5 rule. Again, this is not a real thing, like it doesn't have a name or anything like that. It's just a nice way to check your graph. So to check your graph, you take your a value, so the number in the very front, in front of the x squared, so 2. So I'm going to take 2, and I'm going to multiply it by 1, 3, and 5. So 2 times 1 is 2, 2 times 3 is 6, and 2 times 5 is 10. So then go to your vertex, point to it. You're going to always go over 1, and since it's positive, you're going to go up 2. So go over 1 and up 2, and it should be on the graph. Then you're going to go over 1 and now up 6. And that's where another point would be on the graph. So if there's 1 here 2 away, then you know there would be 1 over here. Then you're going to go over 1, and if you go up 10, it's going to be off the graph. But there'll be another point there. So that's kind of a cool way to check some of your points on your graph. The reason why this one isn't on there is because it's the decimal one. So it's going to go something like this, and then curve, and go like that. So we have our graph. We didn't need to make a table because it required us to graph so many points, and we were allowed to reflect it and then check it with the 1, 3, 5 rule, which allowed us to gain more points on our graph. Okay, so let's go ahead and try another graphing one here, or another problem here. So there's no graph. It doesn't want us to graph. But again, I want to make sure we understand the difference here with number 9 and now number 10. If I want to find the vertex on this problem, I had to do work because it's in standard form. It's in f of x equals ax squared plus bx minus c. So it had the a, b, and c. Whereas this problem here, to find the vertex, we can just look at it and know because it's in vertex form. So you're going to take the opposite of the number with the x in the parenthesis. So that's going to be 2. And then this number out here. So that's the quick way, and the reason why it was so quick is because it's in what we call vertex form already. Then the number in the front of the parenthesis, there's nothing there, so it's a 1. So since A is positive, that's why the graph is going to go up. Okay, then it wants us to find the x-intercept. So that means that we're going to take the equation, and we're going to leave the x in the equation and plug in a 0 for y. So again, to find the x-intercept, you leave the x in the problem. Okay, so then to solve this problem, you could either do x minus 2 times x minus 2 and get this into standard form and use the quadratic formula, or instead, what I'm going to do is I'm going to go ahead and add 1 to both sides. Whenever something has a squared in the problem, I want to get the square alone, and then I can use the square root property and square root both sides. And remember, when we put the symbol in the problem, we need the plus or minus. The square root of 1 is 1, and then this is going to go away. We learned this in the previous chapter. Because the index here is 2, 2 goes into 2 once. So this goes away and leaving us 1 of these. And then we're going to add 2 to get the x by itself. And now we have x equals positive 1 plus 2. And we have negative 1 plus 2. So that would make 3, and that would make 1. So that means our x-intercepts are 3, 0, and 1, 0. So again, just to clarify, we could have done this. We could have done x minus 2 times x minus 2. We could have FOILed that out. I'm going to do it real quick. I'm going to skip some of the steps just to make a point. So then we'd have this. And then you could see if it could be factored, or you can do the quadratic formula. You could do negative b plus or minus b squared minus 4ac. So the quadratic formula works on every single problem. So if we do that, let's see what we get here. So if you were just to show for demonstration purposes here, you'd get 6 over 2, which is 3. That's what we got here. And then 4 minus 2 is 2, divided by 2 is 1. We get the same answer. So again, the whole point of this chapter, one of the big points, is that you have now learned how to solve equations that have exponents in different ways. The quadratic formula, this is the square root property, and we've learned about completing the square, and again, we know factoring. Now to find the y-intercept, we're going to leave the y in the problem and remove the x and put a 0. So 0 minus 2 is negative 2, and then we get 4 minus 1 is 3. So when x is 0,